Hello, Jesus, and good morning, good evening,
Hello.
good afternoon, everybody. Thank you for joining. How's it going, Jesus? Where are you?
It's going great.
Different.
Well, I'm in a different
Yeah.
different room, absolutely. And one of my concerns was actually whether I was going to have a good reception. So please do tell me if things come, all right. So if there's any interruption or whatever. So just to answer your question, I'm in Spain, so I'm
Yeah.
in an unusual location, but not so unusual for me anyway. Spending just a couple of days with family, but yeah, it's a very short visit. So I'll be back in the UK tomorrow. So it was just
Okay.
an accident that we're running this session from here. But why not?
Yeah.
I mean, I
No,
believe
it's fine.
we run one of the early ones when I was in New York at the Knowledge Graph conference. So
I remember. Yeah.
just
Yeah.
to make the webcast more international, right? So yeah. Anyway,
Absolutely.
same quality of content. Doesn't matter where it comes from.
Exactly. That's the most important thing, that we make sure that this definitely hits the mark. And I change location, you change location. I think that's the beauty that we can do this and make it as as available as possible to as many people as possible. So I think that's the core of the target. Before we jump in, I think I will do this until until October, but I'd like to mention notes briefly. Call for paper ended last Friday, so if you missed that, there might be a way. If you say pretty please until end of this week, I might be able to get you in if you want to submit something. So think about it quickly. Otherwise, you can obviously register for notes already. So it's I know now seems October a long way away, but if you want to, the registration page is up and running, so you can already grab your ticket, basically your virtual seat, and be ready for it. So you can do that, and all you need to do is go on the web page. I'll post that on in the chat as well. Let me find the link, which I don't have ready right now. Sorry for that. Here it is. So it's the same I shared generally over the last couple of weeks. But yeah, it's going to be a fun event, very interesting. We're currently setting up the agenda. So in a few weeks, end of next week, maybe already early week after that, you should see early agenda coming together. And I'm looking very much forward to it. So we had lots of submissions. So we have the difficult task now of sifting through all of them and finding the right ones. So that will be done by Michael Hunger and a couple of other for the team. And yeah, I'm looking forward to the day in October. So that's what I wanted to quickly get out. Notes.
Excellent. Yeah, looking forward to that. Should be a great one. Which edition are we at? I mean, it's already been
the
a few years.
fifth edition.
One.
Yeah.
Wow.
Yeah.
Crazy.
Yeah.
Yeah.
Crazy.
Awesome.
Yeah, that's good. But now let's dive in to what everybody has come to see and want to hear about and want to learn about is going meta. So in this episode, the title is Easy Full Graph Migrations from Turtle Stores to Neo4j. In general, the aim of this, so if you maybe are new to the episodes or new to the series and didn't watch all of the episodes, don't worry, you don't have to. This is not it's a continuation somewhat, but it's not like necessary that you didn't have to watch all the 17 now previous episodes.
Well, you're welcome to, of course. And
welcome,
by the way, Alex, I know we're in big numbers now, and it's harder and harder to keep track. But there is a typo there. It's not 17; it's 18 in the banner. So
it's true.
I know when we'll be in 125, it will be hard to know. But it's one of those things. But yeah, no, that's yeah, you're right. I mean, we'll maybe I'll make some references to some of the past episodes, but the great thing is that they're all up there, online, all the recordings, all the resources, everything. If you want to go and reproduce them at home, it's up there. So yeah, that's always a possibility.
Exactly. So everything is there. So if you watch it outside of YouTube right now live, then go to our YouTube page, youtube.com/@neo4j. And then you find our page, and then under live, you see the all the previous episodes, and then there's a Going Meta playlist. There's a Going Meta website, which I could also link. I think I have it in the video description. So there is that. And yeah, we talk about knowledge graphs, we talk about semantics, ontologies, taxonomies. That kind of is the couple of the keywords, I guess, that usually fall when doing this. RDF is a big part of it, and I guess today again, RDF will be something we're gonna look at or talk about when, I guess, also using neo-semantics to work with that kind of data and get it in a it's a graph pattern already, but getting into it in Neo4j and making the data a little bit more usable in certain scenarios, I would say. It makes sense to migrate from RDF data to a graph, to a property graph like Neo4j is one. But I don't want to speak ahead of time.
No, of course, and you're right. I mean, I suppose the content that we cover here is for I think it combines some elements of the traditional sort of RDF or semantic stack with Neo4j. One element, of course, is moving data across from one to the other, but yeah, we just try to experiment, and we've tried all sorts of things. Yeah, some people will find that we're trying things that normally are associated with the semantic stack, but yeah, that's what we like it. I mean, we try new things, and I believe that's the interesting thing of these series. And today you're totally right. So I'm actually going to, if you don't mind, start probably sharing my screen. Is it? Shall I start presenting? Yeah, forgotten. It's been so.
I don't see it yet. So once
good.
it's.
Let me share my screen. It's just the usual couple of slides, so I don't want to take a lot of time, but just go straight into coding. But the idea, like I was saying, it's just one slide because it says it in the box, right? So the idea is to do simple full graph migrations from triple stores to Neo4j. And the idea again is quite simple. We keep reiterating that. So we really value RDF as a standard that makes it really straightforward to exchange graph data. And that's been a theme during this series. And I'm happy to be aligned with the W3C. If you go to the page, it is actually defined as a standard for data interchange in the web. So it's, like I say, a great way of streaming out your graph or ingesting graph data in a format that's neutral. That it's as we're going to see, it's entirely independent of the way you store your data, you persist your data, and it's important also to understand that my position, personal, but I think it's a shared approach at Neo4j, is that while we find RDF a great format for exchanging data, we have the impression that developers, data people tend to feel more comfortable with the level of abstraction that property graphs offer. And again, I when I think of Alex and me in a graph, I see two nodes, right? And there's connections between us because we work together, because we're friends, because we run these webcasts together, because we have common friends, right? So, and it's easy for me to think in those terms rather than kind of decomposing Alex in statements as, Alex's date of the start date at Neo4j is XYZ, or Alex's name is Alex Erdl, Alex's employee number, blah, blah. So, which is exactly the idea of RDF. I mean, in terms of working with data, manipulating data, I'm very comfortable with the level of abstraction, again, that the property graph offers. And Cypher is a great environment to manipulate the data. But I appreciate, and that's exactly where we're going to see here today, that if I want to exchange data, RDF is a great mechanism. And that's the topic for today. And the idea is pretty simple, right? So I'm going to play with a couple of popular triple stores out there. In particular, today I'll use Stardog and ontotext. I was working on Neptune, but I didn't get it, to complete. So I'll add it to the repository, but we probably won't cover it in this session. But the principle is identical. I mean, these three platforms store data as RDF, and because RDF is just, like I said, easy to stream out of a platform and easy for us to ingest, thanks to Neo semantics, the migration is going to be really, really straightforward. That was where I introduced the easy full graph migration in the title, but it's that's the idea. Does it make sense, Alex?
Yeah, that sounds good.
Perfect.
And
so
maybe before we dive in, there was one comment.
Sure.
From episode 17, the repository folder is missing.
That is right. Yeah, and that's entirely my fault. It's true that it was a bit probably the most experimental of all of them, and it's the one where we tried the OpenAI interface. It was kind of, I had mixed feelings about the results, but anyway, yeah, I'll put it all up there. Sorry, I'll make sure that happens after today with both 17 and 18. Yeah, thanks for
thank you, Jesus. Thank you for the comment. So we don't forget about it. Yeah, that sounds good. I think that makes sense. That's probably a common path, I would say. Or lots of people might have the same, not necessarily challenge, but maybe think about doing it or want to do it, or have a data store similar to this and think, okay, hey, what do I need to do if I were to be migrating this over? And I think that's great to show it how it works and how it could be done.
Yeah, and that can be, it can be, of course, a migration because you want to work on a property graph, because you want to run some analysis in Neo4j. Let's say you want to run some graph algorithms and then enrich your graph and then bring it back to your triple stores. Whatever the logic. In this case, we're going to be just focusing on the pure migration, the moving data out. And what we're going to see is that depending on which environment you work on, and today's environment, just last slide, is a Python notebook. But depending on what environment you use, I mean, you will have additional tools in the form of drivers. For example, Startup will see that they offer a very nice Python driver that makes it really, really easy to work with on a Python notebook environment. OntoText, I haven't been able to find one. It might be my fault, but what I'm going to do is just purely using HTTP requests, which is something that we can do in a notebook environment. But again, depending on what's the environment you want to run your migration on, you will have better or more or less support. But these two approaches that we're going to see today cover kind of at least two options for these. And like I say, Neptune, I'll add it later on to the repository, but the ideas should be entirely valid. So let's get started. Good. So what I've done is I'm going to work entirely in cloud instances. So for Neo4j, as usual, while we were starting, I created a sandbox, which should be now up and running. Perfect. So we have it here and the connection details and everything. We have, I've done the same with Stardog. I mean, I've looked at the free cloud offering, and I've created a simple database that I've called migration test, and I'm going to interact with it through the Stardog Studio, which is again the equivalent of our Neo4j browser to interact, to write some queries and get the results. Of course, because this is RDF, we'll be writing Sparkle, but the idea is pretty similar. So I will not spend too much time because the focus today is on the migration itself, right? So, but just so what I did is I created a database that I called test database, and it contains music data. Again, it's a data set that Stardog provide, and I think I have a couple of URIs here that are going to be useful, so I can show you what that can look like. But if I want to extract information about Nirvana, the band, we will be able to write something like this. This is the URI that uniquely identifies Nirvana, and I want to say, well, tell me all the triples that have Nirvana as the subject. I'm going to call this predicate and object, and I'm going to return precisely that, predicate and object. So if I run something like that, this should return, well, everything we know about Nirvana. Well, not everything, but because it's just the outgoing triples, not the incoming one, because you have to be specific about that. We'll look at that in a minute. But we see things like, Nirvana is a band, is a producer, is a songwriter. We have a description of it here, which is a longer text description of it. It has a name, Nirvana the band, and it's connected to a number of individuals through the member relationship. So we can I don't know, we could extend that query and say, okay, if I follow the member predicate, I would get to the actual members. And maybe I would like to get for these members some predicate object information about them, right? So, and I could actually return the member as well. So, well, I said that I wasn't going to do it, and I've done it. I forgot the dot. So I don't want to spend too much time basically running queries here. But, the idea is, it's a simple data set that again, it's a public one, and I'll share the link. But here we get the information about the members of the band, right? Kurt Cobain, Dave Grohl, and Chris Novoselic. So, yeah, that's, like I say, an RDF-based database that we can query with Sparkle. But today, we might just check that things have been migrated correctly with the query. But the idea is not so much exploring it, but looking at how to migrate. And like I said before, I have created this notebook where I'm going to basically write the logic. And I'm going to take you through it. I'm probably going to make it a bit bigger. Alex, tell me if it's readable.
Oh, this is readable. Yeah. Maybe I need to put our faces a little bit further. Let me get that done. But yeah, you can continue.
Perfect. So I'll as I mentioned before, Stardock in particular offer a nice Python driver, which is the one I'm importing here. So I've run pip install for the PyStardock, but also for Neo4j. And after the imports, what I do is I pass the connection details. Of course, you can copy those, but I'll disable them so don't so that you don't use my. But anyway, that's basically where the instance, the endpoint, which you get from your Stardock Studio. So you get easily from here. So you get the endpoint URL. So that's pretty much what I'm using there, and this is the connection details, user and password. So you start a connection, right? Pretty straightforward. So you use the credentials and you indicate the database that you want to connect to. In my case, it's test database, which is the one that I was showing here. There's, I think there's another one that comes by default, the catalog, and you can create additional ones, but I'm using the test database. So that's what I'm doing here. So I have a connection now. And again, this optional part is how I loaded the data, because by default it was empty. So this is, I'm not going to run it now because the database is already loaded. But basically, I imported the music dataset from this URL, which is again another one provided by Stardock. What's interesting and where we're going to focus today is this section here, and that's all. That's why I said it was easy. So this block here is all we need. So basically, what we need to do is we have to create a connection on the other side.
One more step, Jesus.
Sure, absolutely. Even does that look better?
Yeah, that's perfect. Yeah, thank you.
Good. So, I mean, that's a previous instance. So let me make sure that I'm pointing at the right sandbox. So let's open it here. And while I do that, I'm going to look at the connection details. So the URL is this one. So I'm going to copy to the clipboard and get back here and replace it with the right one. So that's my database. That's my authentication. Probably the password has changed as well. Let me copy it here. So it's Neo4j, and this is the password. There we go. And I'm going to use, I mean, I can decide to use the database that I prefer, but I'll use the default one, which is Neo4j, right? Which is created by default and which should be empty. Let me connect to it through the browser like this. I can see what's in there. And while that connects, I'll keep moving here. So what are we going to do? So we, same way we created a connection to the Stardock database, I'm going to create a connection to the Neo4j database. And these are the credentials and the URL. And once I have the connection created, the driver created, which I've called NeoDB, I'm going to initialize it. You know that before we can import RDF, in order to use Neo4j, we have to both create a constraint that you might have seen me create, every time I use it. But again, won't spend too much time on the details. That's a requirement. That's what this statement does. And then we need to initialize the way we want the RDF to be imported. I'm going with the defaults. So I'm calling the init in Neo4j, the graph config init, and then I actually go ahead with the actual migration. And the migration is as simple as if we start from the end, we're calling on the connection that we have to Stardog. Remember this con here is the connection that we created to the Stardog database, to our Stardog cloud. And they offer a quite convenient function that's called export. Right? So that's exactly what I'm using. So the export returns bytes, so I have to decode so that it transforms it into a string. But that's the RDF as it's streamed by the export function is the thing that I'm directly ingesting on the Neo4j side. And to do that, again, you might have seen many times us using the RDF import method in Neo4j that takes RDF in any serialization. By default, the export produces turtle, which is what I'm specifying here on this side. And what as you can see, all I'm doing is, import whatever comes as a payload. And the payload is a variable, a parameter that I've set as the output of these export on the Stardog side. Does that make sense?
Yeah. Yeah.
So that's it. So let's run it and let's see what happens. So
this indeed sounds very easy.
Yeah, exactly. So it's pretty much. I think I've run most of these, but let's rerun it again in case some credentials have changed. So I set my connection details. I create the Stardog connection using the driver. I'm not going to populate the database because it's already populated. And what I'm going to do here is, like I say, initialize my Neo4j database, which by now should be already up and running. So we can see it here. I'm going to do something because, I don't like when it connects things for me. But yeah, it's the Neo4j database is absolutely empty, no labels, nothing in there. And let's run that step here. So all we need to do is now it's happening. Actually, it's exporting the database, and at the same time is importing it here. Then we close the transaction, and hopefully that should leave us in a state where we have the graph loaded on the Neo4j side. So take a few seconds, but what we're going to try next, which is obviously the proof of the pudding, all that's done. It's not a very large data set, but we should see now on our Neo4j database that we have a bunch of albums, producers, bands, artists. Again, those of you who have seen Neo4j, Neo4j before, you know that everything is prefixed. If we didn't specify, and we didn't, it will assign numeric prefixes NS0, 1, 2, 3, because in RDF, everything is uniquely identified with URIs. So that's, I know it's not the nicest thing, the NS0. We could have assigned a nicer prefix. We didn't do it, but it's not the point of this session. There's plenty of previous ones where you can see how to do that. But what's important is that now, like I say, we have the data in the graph in Neo4j, right? So if I click and want to look at some albums, and here's where you see how my Wi-Fi is a bit flaky, but anyway, let's take one of them anyway. So let the music play. That's by Barry White, but you can see how a node, like we said before, right? The node Alex aggregates all the statements, all the information that we know about Alex. So the same here. So we have a node representing this album, and it collects all the triples that we have ingested. So for example, the release date, the description, the name, the URI. So all this happens, transparently, and that's what Neo4j takes care of. But now we can start navigating and see that, this album is produced and actually performed by Barry White. It has a track that we can keep expanding. I don't know in this case, but there you go. It's also connected redundantly to Barry White. There's another writer, and so on and so forth. So we can keep expanding here. So that's it. So migration couldn't be really easier, because literally, again, thanks to the entirely generic nature of RDF, we don't really care about the types of entities. There's no notion of tables. Okay, I mean there is, and we could be more precise, and we could say, hey, just load that portion of the graph. But if we say whatever you find in this triple store, just dump it into Neo4j. RDF does the job. I mean, it's already a graph, so it's streamed as a graph as triples, and then we ingest it on the other side, and we have exactly the same information. And I think that's very convenient. I mean, now, I get some comments when we import. This is a small data set, and when you import larger ones, it might not be the most efficient format, and it's absolutely normal, right? That's I mean, you have to think of RDF, and again, we can look at that. Let's go back to the studio just to look at it for just a second. So this is a triple, right? So for example, we say Kurt Cobain is of type songwriter. We know it has a description. So everything is a statement. And each statement is self-describing, is an atom of information on its own. I mean, if you think of it as I mean, these are the three members of the band. If we were thinking in tabular terms, you probably would have a table of members or persons or individuals or artists, where you would have maybe a column with a name, a column with the description, a column with the label. I mean, whatever you have in this database. And for each line, you would have specific fields. So a triple is like each of those fields on its own. Basically, you provide the coordinates, right? You provide the X coordinate, which is what's the primary key, the unique identifier that something applies to. The Y will be the column. In this case, I'm providing the name, and then actually the value. So each atom of information, each field, if you think of it in a data set, is a triple, and you have to provide the X and the Y. Now, while that isn't super generic, and it's great for data exchange, and it's great for aggregating data, I wanted to combine the data that comes from Stardock with data from other parts. I mean, I can bring it all, and it will link nicely, assuming the schemas link nicely and everything. But where I was going is this is super generic, but it's not the most efficient. I mean, if you stream data like that, think of the huge amount of data redundancy that you see. So the subject is repeated at every triple. The predicate will be repeated every time. So, and especially these days when we're getting used to formats like Arrow that are super efficient. I mean, all those formats that exchange large volumes of data are based on the idea of defining repeatable structures. So if you define a data frame with columns, with fields, then you can compact it a lot more and do a lot more compression. RDF is super generic, but it will not be the most efficient way of changing data. So be patient if you're loading a large data set, and that happens, across the board. I mean, moving data into Neo, out of Neo, into triple store, because of the nature of the format itself. So it's what it is basically. But I think it kind of did the job in terms of hey, that was really genuinely easy, right? So and I was saying, let's check that what we have done was what we intended, and basically the intention of a migration is that at the end of the process you have the same information on the new store as you have in the original one, right? And we have the tools in Neo4j to prove that. Let's take, for example, and I think another URI here, Shake It Off. Right, one of my daughter's favorite songs from Taylor Swift.
So everybody gets the earworm for the rest of the day.
So let's find that song, and again we can look it up on the. I mean, we could continue with Nirvana, but I'm taking these ones. So we have this URI that uniquely identifies a resource. So if I return that would be the song identified by these URI, and as we can see, it's connected to a number of individuals. Taylor Swift as the right. I mean, it seems to be code written by a number of individuals, and it's part of an album that's where the track is found. So Right. So let me again go back to my cheat sheet here. So I have these. Well, I'm actually gonna write it so we can go to start and say I saved it here now that I remember. So this is a generic triple that would get me everything we know about Shake It Off, right? And again,
Okay.
because let's try to dissect this. But basically, I'm saying give me every triple subject, predicate, object that where either the subject is Shake It Off or the object. Basically, what I'm saying is give me all the triples that are where Shake It Off is the subject. So like, but also the ones that for incoming relationships where Shake It Off is the object. So if I run this query, that should return me in this case, well, just 8 triples, which is pretty small data set, easy to test. And then I go to the Neo4j side, it would be something similar to that. But in order to get the relationships, I would need to do something like that. I mean, incoming and outgoing. Let's call this rel, for example. And I'm going to return r and rel. So what I'm returning is all the triples about the Shake It Off song itself, but also any relationships that come in or out of it. So if I do that, and I put it on my RDF endpoint, which I get by running post RDF Neo4j, which is the name of the database, and Cypher. So I'm using the Cypher endpoint. So my query is this one. Oh, and I have to, of course, avoid the double quote inside double quotes. Let's make these one single quotes. But basically what I've done is I've pasted that cipher, and I'm going to run that. And that returns the RDF, but I like it more in, let's make it format n triples, because it's going to be more similar to the format and triples. Now it looks like subject, predicate, object, and it's easier to compare. But we see that 1, 2, 3, 4, 5, 6, 7, 8. The 8 triples that we're getting on the other side, right? So if I look at my studio, I get exactly the same collection of statements, right? So for the same query. So important to see that there's no data loss, and that the information that has been imported has been totally preserved and can be regenerated, which is another important aspect. If you want to, like I was saying before, right? Maybe you want to, you've loaded your data into Neo4j, you want to do your analysis. You could even, actually, why not? Let's run it as a background thing here. Let's try to open this in Bloom, and yeah, let's say you have it in Neo4j because you want to run some algorithms and then enrich your graph and eventually bring it back to your triple store or do whatever with it. So so yes, that's pretty. I would say mission accomplished. So we have migrated the data in a very, very straightforward manner, and we have seen that that the data has been preserved. So that's test number 1. And well, if this one's up here, let's hang on, let's run it. Neo4j and the password. I don't know if I'm doing this right. Am I supposed to enter it twice? Right?
No, I think you didn't enter it the first time. Now should be good now.
Okay, so that should be
it's good.
Don't want to save that. So that should let's do a quick test, because one of the cool things in Bloom is that we can run the algorithms without having to write code, right? And that's something that anyway, well, I'll leave that because it might take a few seconds to initialize, and I don't want to diverge, distract the attention from the topic of the day, but we'll get back to that. Good. So that covers the first, the first example, right? So RDF data in Stardock, we move it out with this export statement, and again, you can be a way more granular. I mean, we're going with a full graph migration, which is what export does. But of course, you can be more selective, more precise, and say, hey, I'm going to write a query and specify the portion of the graph that I want to import. And, ultimately is exactly the same. So you can be more granular, but what you would be doing is, like we described in the graph here, you're streaming out RDF, and Neo4j is persisting it in Neo4j. So same idea is still valid. Now, if we move to the other database, to the triple store that we're playing with today, which is OntoText. This has gone to sleep. But again, they offer, it's not like a sandbox environment, but it's more kind of a public data set. And in particular, this one is a demo data set on the I4j knowledge graph. So it's like it's an ontology. In this case, it's a schema. So kind of a model for industry 4.0. So if we I think there was a link here to
kind of
exactly. I think that's I can open here a tab for additional information, but it's it's an ontology where we define a number of concepts, and well, that's kind of the visuals of it, and it's preloaded in OntoText in GraphDB in the form of triples again, and we can run some example query. That's a very the one that comes by default, getting all the triples here. But again, subject predicate object is the format. Now, if we go back to our notebook, the problem is, like I was mentioning before, is I couldn't find a driver for Python driver for OntoText. But again, the idea is pretty simple. It offers a Sparkle endpoint, and that's the URL of it. That's the one, as you can see, that I get from here. And all I have to do is write a full generic query that basically streams out every single triple of the graph. Right? That's what it looks like. And, so it's basically take every triple, and we can test it here. It's very similar to this one. So it's a construct query as opposed to a select query in Sparkle. It's one that returns triples, right, instead of tabular results. So I can set a limit here. Basically, I'm saying take any triple, subject, predicate, object, and stream it out. And I can say put a limit of 10, and I can run that. And that will, I could put the raw response, and it shows, subject, predicate, object. But you can download it. I mean, you can export it in any of the RDF serialization formats. So that's my kind of workaround for that type of scenario. So I don't have that nice driver, but I can say, okay, run this query, and that's an HTTP endpoint. So I'm using the request module in Python, and I'm saying, okay, get, which is basically a get HTTP request on this endpoint, which is where the database is located. And these are the parameters. There's a query, which is my full generic query, that is take anything and bring it on. And I'm specifying the serialization format. Like before, I'm using turtle, but could use any other. So basically that returns an export result in the form of the result of a get HTTP request. And what we're doing, and this is literally copy paste from the previous one. So I'm going to connect to my Neo4j instance, and I have to update that with the new details, because that's in the previous example. So connection details, that's the new URI. I'm going to replace the old one. And I'm connecting with the credentials that appear here. So replacing that. And I'm going to create a database so that we don't overwrite the other one that I'm going to call I4j knowledge graph. So let's go to the database, and I can do create database I4j knowledge graph. It will take a few seconds, but like this, I kind of work in two separate environments. You see that the database is already available. So I can now, from my notebook, I can, like I say, it's a copy paste. So I'm starting a connection, but this time on a different database, I4j KG. I'm initializing it exactly in the same way. I'm creating the constraint and initializing with the default options. And then what I do is, okay, if my request before return at 200, which in HTTP terms means okay, success, then what I do is I do exactly the same thing as we did before. We call the RDF input inline, and the payload that I pass is the text returned by the export that we run before. These export up here. Does it make sense?
Yeah. Yeah.
So it's,
and if you were to do this without having previously loaded anything or haven't, you can just keep the database as Neo4j. But
yeah, I mean, we could.
In this case, it makes sense to do a different one. But yeah, it's very similar. It's almost like you said, it's almost the same thing.
Literally, if we go back here, is copy paste, except even the last line, except that the payload, instead of getting it from calling the export in the driver, what I'm doing is getting the result of this HTTP request. But the concept is identical. So both operations, one more Pythonic, not more Pythonic, but more driver rather than an HTTP request, is producing the RDF, and I'm consuming it. So if I have made no mistakes, let's give it a go. So this, did I don't know if I run this. Maybe it will still exist from my previous execution, but that's again, it's a small data set, so we should have it.
See,
so there you go. So that's
it.
Did
get. Yeah.
So
at least there's something there.
Yeah, so there's all the, because it's an ontology, there's lots of types, lots of labels. But again, we can run a simple test, and I have my cheat sheet here with some URIs. And if I go to my Sparkle endpoint, I'm going to look at, for example, one of the concepts, which is this one. Instead of a construct, I'm going to use a select start from here. So basically, I'm returning all the statements, I mean, the predicate and the object about a standard organization. So if I run that, and I want to put it in the form of a table, we see that standard organization is a class. Actually, it's class according to RDFS, class according to OWL. It's a thing. It's the same as a standard organization. Well, you see, there's 10 triples here. I'm limiting it to 10, so maybe there's more. Let me remove that limit and see what that returns. But no, it's actually 10 anyway. So and there's a comment label and some other equivalent classes. So if we try exactly the same query on the Neo4j side, we should check that the input has been successful. So that would look something like match. I mean, I'm looking up by URI, which is the quickest way of doing this, but and actually we would get, in this case, I believe we were specific about the outgoing ones, because I only put the ones that had these as subjects. So if I return R and rel, that will return the visuals. But again, what we're interested in is in the post request on RDF. This time, instead of Neo4j, is I40 kg database, and I'm going to use the cipher endpoint. And just like before, my cipher query is this one. And as always, I have to be careful in the browser of the quotes, the way we're using them. And that should be it. But just like before, because it returns, if not total by default, I'm going to say the format I want is n triples. And that's again entirely because it makes it easier to compare. And we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triples, just like the other case. So we have the thing, we have the class according to OWL and RDF schema, the equivalent classes, which were standard organization and same as. So pretty much the same information, well, not pretty much, exactly the same information that we get on the other side, right? So these 10 triples. So no data loss again, and like we saw before, entirely possible to completely regenerate the RDF as it was imported. So in case we wanted to bring it back for whatever reason. So yeah, I think I should probably put a comment in the, because this is the onto text example. Let's make it clear. But yeah, that's pretty much it. Hope that was clear and simple enough, because that's again one of the requests that we often get from our Neo4j users. How can we do a simple migration? And yeah, it doesn't get much simpler than these in terms of migrating data from one platform to another. And again, this is something that we've shown in the past that doesn't work only triple store to Neo4j. We've also used it to move data between Neo4j and Neo4j. So sometimes it's a convenient way of moving data from one instance to another, a whole graph or a portion of the graph. So again, keep the idea that, as we said at the beginning, the RDF is a great model for data exchange. Very flexible, very easy to use, but also with the caveat that, don't expect the best performance, because we're literally streaming atom by atom of information. So take a pause here and see if we have any questions. Does that make sense, Alex? Did that kind of cover the topic clearly? Ooh. What happened? Did I can't hear you. I don't know if it's...
Yeah, because I'm muted. I was wondering, that was very clear. Thank you, Jesus. The question I had was, is Stardock and OntoText, as the two examples you showed, did you pick them because they are the most famous ones, or is this a particularly easy example, or is this the procedure you would go for no matter what triple store you use in general?
Yeah. So I think that they're some of the most popular. I mean, I mentioned in the slides these two plus Neptune. I work locally with Neo4j, which is another, it's more an API for Java API to work with RDF, but also offers kind of a mini triple store. But these three are some of the most popular, some of the ones that our users mention more frequently. But the idea is exactly the same, and it's the great thing is that they all share the fact that they offer an out-of-the-box RDF, because they natively and store the data as RDF. They expose it as RDF, and that's a format that we can easily consume. So yeah, probably the most popular, but the principle is exactly the same with any RDF store.
Okay, good. And then there was a question from Y. What's the advantage and drawback of migrating a triple store into a Neo4j? I think you mentioned some of those, like you say, streaming atom by atom can be a little bit slow, and it's not a high performance. So, I mean, if you have, I guess, if you have the same data available as CSV, would you prefer to go via CSV import, or would you still do the RDF route?
Right. Okay. So yeah, if I had CSV data, and I mean, I would need to choose. I mean, because I suppose the question here is what type of graph store you want to use, and that's kind of the I would say the question that's been going on forever. And whatever I say, it's going to be biased, but I think at least I try to be objective and articulate my answer. So I really value RDF as a format for data exchange, and we've proved how it's extremely useful to very simply have a graph and reproduce it on a different platform. But it's not, and again, that's my impression, but I think it's backed by the fact that I don't know, go to Stack Overflow and you will see how there's surprisingly or unsurprisingly more questions tagged with Cypher than they are with Sparkle. maybe that is because the developers, ultimately the people who interact with Stack Overflow, are the people who are building software, asking questions. That's because they're facing these type of issues. So I believe that working with data as a graph, I think it's a more natural, closer to developers, closer to data people, the level of abstraction that Neo4j offers, that the property graph offers. That's my intuition, and that's what I feel. But again, if you talk to maybe some startup guys, and they will say that no way that this is so. Yeah, and then that's looking purely at the model, at what the data looks like, and what the experience of interacting with the data from the point of view of your query language and the model. Then beyond that, of course, there's a whole host of questions that you have to ask yourself in terms of what's the underlying data store, because things like what type of workloads, what type of high availability you want, what type of, do you want an open source platform? I mean, there's so many questions that you need to ask, and that are not model dependent, but more platform dependent. Then, again, I would have plenty of opinions that I would be able to justify, but I think, whatever I say, people might take it with with a pinch of salt, because they might say, hey, you work for Neo. That's true. But we're doing these webcasts where we try to kind of be objective about the two things. So I hope what I say gives you some hints and some clues and some ideas of the kind of things that people look at when working with graph data.
Yeah, I think that makes a lot of sense. I mean, in general, we try always to say, use the data, use the tool that fits your data, and no matter what you do, think about, what kind of data model do you want to go with, but what kind of challenges do you have with your data? What's the ultimate outcome you want to achieve by using data, and what in terms of data combined with a platform. And if you realize that maybe you want, like you said, right, you want to do a little bit more with your RDF type data. You want to do some algorithms, some graph algorithms in particular. You want to find out a little bit more about the connections beyond the first degree, which is, I think, super easy visible in RDF. But if you go a little bit further, 2, 3, 4, maybe more steps, it can become more complicated, and then it can become a little bit more overloaded. Might make sense to at least look at it in a property graph way, and see if that helps you with that approach.
Absolutely, yeah. Integrations. I mean, what kind of ecosystem you work with? Where are you going to get your data from? What kind of which are the options? I mean, we've seen today that if you want to get data out of one of these platforms, you have different experiences. If you're a Python writer, maybe you prefer Startup because they offer you this driver than Onto-Text. Things like that are important. How you're consuming your data, what kind of visualization, what kind of integration, like you say, with analytics, with machine learning, all these elements are important, and it's a big decision, and you have to do your due diligence when you're starting a project and try to understand which benefits one has compared to the other. I mean, today we were just focusing on the mechanics of moving data across and showing how the RDF gives us a really straightforward way of doing it. But all those questions are relevant, and you have to, of course, answer them before you choose the type of platform that you want to use to manipulate the data.
Yeah. That's always true. Always think about that, and then do some testing, do some evaluation, obviously, and see if that works. And we showed with free tools, at least from our side, you can give it a go and see if that is something you see is maybe worth further exploration. Sorry. There's another question from why, and I don't know if I missed something here, but is there a competitive modeling tool for GraphDB, such as Neo4j of Protege? I think we talked about Protege before, but I don't know if modeling tool. Is it like something like Arrow, or?
Yeah, it could be. It could be. I mean, that's we often use Arrow as a modeling tool, but again, we've shown, like you said, Alex, I think only a couple of, I can't remember how many, but we've shown how you can perfectly use a Protege as your modeling environment and create your ontologies. And then the model that you create with Protege, I think in one of the episodes, we use it as the target model to ingest data in the graph and to automatically build the pipeline. We've also used it to, I think the last time was to create a Streamlit application that would read the ontology.
That was it.
Again, these tools, Protege, Pool Party is another one. They produce models in RDF, and we've shown how easy. The moment it's RDF, we can bring it into. You can create programmatic. How would I say, actions on it, whether that's to ingest data, whether that's to run inferences, whether that's to run validations. So yes, there's arrows as an option. There's the data modeler as well, which is kind of a variant of arrows as well, right? That's the data modeling tool that's part of the workbench.
Exactly. That's a version of it.
But I would say that use the one that fits your need, and will and you will find possibilities for interoperability again in some of the episodes in this series.
Yeah. And then there's a question, I think, so two questions, more or less in the same vein. How is it, or can you explain how the Neo4j knows what to do with what, basically? So how does it know that something becomes a node and something becomes a relationship?
Sure, that's pretty straightforward. So it's I think it's described in the documentation, but I can put a pointer. It's basically 3 rules. Triples come in two shapes, right? So a triple can have and maybe I can start sharing my screen again just to show an example. So let me share it again and maybe bring the Stardog. So this example we're showing, can we see my screen? Am I sharing it?
Yep. Yes.
Cool. So this is a collection of triples about the song "Shake It Off" that we mentioned before, right? So as you can see, there's 2 types of triples. Let's call it types, but these 3 at the bottom is what we call literal triples, right? And they're literal because the object, the 3rd component of a subject predicate object, is an actual we call it literal value in RDF, which is a string, is a number, is actually a property value in a way, right? So these literal triples become a part of the node structure. So all the ones that contain that share the same subject, for example, Shake It Off, will become a node, and all these will become attributes of the node. So literal triples become part of the internal structure of the node. And then object triples, which are the ones that have in the object another resource. These are relationships. This is a connection to something else. So for example, we're saying that Shake It Off has a writer, which is Max Martin or Taylor Swift or these other guy. And so this is another thing, another resource that will have itself, we can actually check it. So we can take this Max Martin and say, what do we know about Max Martin? And we can keep navigating the graph. And so if we do that and run the query, we will get all the triples about Max Martin, right? So there's a bunch of them. And again, we'll see that some of them are incoming, some of them are outgoing. But in this case, we can see here at the bottom, let me hide that Max Martin has a description, has a name, so some literal properties as before, which would become part of the internal structure of the node, and some relationships that will connect Max Martin to other things. So these are the 2 rules. And then there's a 3rd one where we have type nodes. And type nodes in RDF is a keyword, RDF type, which basically gives you the class, the category that this resource belongs to. And in this case, this is a songwriter and a producer. So these types can be represented in Neo4j in 2 different ways. So you can use what we call in Neo4j a label, which is a tag that you associate to the node, which is the option that we use by default. or you can create a separate node and link them together through a type relationship. But these are just the three rules that we apply, and that's what semantics does. Under the hood. I mean, not under the hood, but internally, as you ingest, which is the kind of standard, natural way of importing data. Let me stop sharing. Yeah, so that's it. I believe it's described. I can send you a link to a post where I describe that. I'll maybe put it in the chat, but that's it. The logic is pretty simple.
Yeah. Yeah, that's good.
Dated, but shall I put it on the? I'll put it on the chat for you, Alex, and then you can.
Yeah. Put it in the chat, and then I'll put it. Perfect. Thank you.
So that's basically a longer description of what I just described. Yeah.
Yeah. I'll put it also in the video description, so so people will be able to find it.
Yeah, and I appreciate that we've just focused on the migration part, and we kind of assumed that people were familiar with this, but yeah, again, there's plenty of previous episodes that we can look at for more details.
Absolutely. I think that's it for today. Thank you for watching. Thank you, Jesus, for showing this. I think this is very good. I mean, if any episode seems to me like the best one to try out at home, basically, is going to be this one, because it just seems to be 3 lines of code, and then you're good to go.
Absolutely.
So it's very friendly and very makes it very easy to try and see. So if you are on the fence of giving it a spin, see what Neo4j can do with RDF type data, and if that works for you, then this hopefully we showed you how in this episode. In terms of upcoming sessions, tomorrow at the same time, so 5 p.m. Central European time, I have Maria De Maro as a guest, and we talk about linguistics and graphs. So she wrote a paper on that. So how to analyze conflict dialogue, argumentation-based dialogue in NLP and graph. So that's should be a very interesting session tomorrow. And yeah, I'm looking forward to seeing you then. Hopefully you can make the time. And if not, obviously all the episodes will be available as recording on YouTube. So just go to our YouTube channel and you find all the playlists of Going Meta, also the other channels, the stuff we're doing. So just check it out if you want to. And if you like it, then please give it a thumbs up, or better yet, or both actually, subscribe to the channel or follow the channel. That would be nice. Thank you, Jesus, again for presenting, for giving the demo, and for showing how easy it is, and obviously, for taking the time today. I'll see you soon.
Perfect. No, my pleasure. See you soon, and I'll make sure that all the content for 18 and 17 is up with the rest in GitHub. So thank you all.
Perfect. Thank you very much, and have a good rest of your day. Bye bye.